Here we're going to learn how to add rational numbers. Now what we're going to do is we're going to look at a few examples of how to add rational numbers in the traditional method. And then I'm going to teach you a method that makes things a lot simpler, but for some reason isn't taught in most schools. And then we're going to end up by looking at an application of adding rational numbers. So here we go. We're going to add 2 over 3 and 4 over 5. Now the first thing we want to do is find what's called an LCD. LCD stands for lowest common denominator, and all that means is we're looking for the smallest number that is divisible evenly by both denominators. And we want to use that to transform both fractions into 2 fractions that have a denominator that is the same. And it's going to be our LCD. So what do? 3 divides evenly into what? 3, 6, 9, 12, 15, and so forth. 5 divides evenly into 5, 10, 15, and so forth. So it seems like our LCD is 15. So let's write both fractions with the denominator of 15. So let's transform one at a time. Let's do 2/3. 3 times what will give us 15? Well, 3 times 5. What we do in the denominator, we need to do in the numerator. We're essentially multiplying 2/3 by 5 over 5, or 1, which essentially doesn't change the value, it only changes the form. So 5 times 2 equals 10. So 10 over 15 is the same as 2 over 3. Let's do 4 over 5 now. 5 times what will give us 15? Well, 5 times 3. Whatever we do in the denominator, we need to do in the numerator. Multiply by 3 up here as well. 4 times 3 is 12. Now we have 2 fractions with a common denominator, so in our answer we just carry the same denominator and add across the top. Our numerators are 10 and 12. 10 plus 12 is 22, and that's our answer. Let's do another one. Let's say we have 7/3. We want to add this to 5 over 6. Okay, what we want to do first, we want to find our LCD. LCD. Well, this was a little simpler because 3 will go evenly into 6. So that's our LCD. We actually only have to transform one fraction and rewrite the other. We want to transform 7/3 into a fraction that has 6 as a denominator, and we'll just bring down the 5 over 6 since it already has 6 in the denominator. 3 will go into 6 how many times? 2 times 3 equals 6. Let's do the same in the numerator. Multiply by 2. 2 times 7 is 14. And then for our answer, we carry the same denominator and add across the top. 14 plus 5 is 19. And that's our answer. Let's do one more this way. Let's add 1/8 and 2/8. Well, here we don't even have to find an LCD because they have the same denominator already. So we carry the same denominator. 1 plus 2 is 3. So 1/8 plus 2/8 is 3/8. So most fractions don't come with the same denominator, and you'll have to find an LCD going this way, but this one was much simpler. Now I want to teach you a technique that makes things even more easy. We want to write it in algebraic terms first, and I'll show you that it works in the general case, so you can use it for adding any fractions or subtracting any fractions. So let's say we have the fraction a over b. We want to add the fraction c over d. What we're going to do is take the cross product. We're going to multiply a times d for our first term. We're adding, so we're going to put an addition sign here. We can also do this for subtraction, which we'll see in the next section. And we're going to multiply for the next term b times c. And this is going to be all over b times d. So these 3 steps take finding of the lowest common denominator completely out of the question. Let's do an example using this. Let's add the 2 rational numbers, 1/4 and 2/7. And let's use our cross product doing this. So first term is 1 times 7, which is 7. We're adding, so we have our addition sign. 4 times 2 is the second term, which is 8. And the denominator, 4 times 7, is 28. 7 plus 8 is 15. And we carry our denominator, and that's our answer. Now let me switch colors and do it the traditional way just to prove that this works. Let's find an LCD of 1/4 and 2/7. Well, the LCD happens to be 28. So let's transform 1/4 and 2/7 into fractions with 28 as a denominator. So how do we do this? 4 times what will give us 28? Well, 4 times 7. Multiply the numerator by the same thing. 7 times 1 is 7. And now let's do 2/7. 7 times what will give us 28? 7 times 4. Do the same thing in the numerator. 2 times 4 is 8. And this is looking pretty similar. Carry the same denominator and add across the top. 7 plus 8 is 15. And get the same answer. Let's do another one. Let's add 1/2 and 5/12. Well, we do the cross product. We multiply 1 and 12. 1 times 12 is 12. We're adding. 2 times 5 is 10. And the denominator, 2 times 12 is 24. We carry the same denominator and add across the top. 22 is 12 plus 10. And we want to write this in lowest terms. And both these numbers are divisible by 2. And this simplifies into 11 over 12. Let's do another one. Let's add 2 over 9 and 3 over 7. And we're picking larger numbers here just to show you that using this method is quicker than trying to find an LCD, going through all the common factors of 9, the factors of 7, and searching for an LCD. I just want to show you that this is a much simpler method. All right, so we're going to have our first term is 2 times 7, which is 14. We're adding. Second term is 9 times 3, which is 27. And our denominator is 9 times 7, which is 63. 63 is our denominator. Add across the top. 14 and 27 is 41. 41 63rds is our answer. So using this cross product method, for some reason isn't, like I said, it isn't taught much in school, but it saves a lot of time over finding an LCD and using it the traditional way. So you might want to check with your professor or your instructor which way they prefer so you don't get in any trouble. But even if they want you to use the traditional method, this is always a good check. Okay? Now let's look at an application of adding rational numbers. Alright, so we have the following problem. Jake is planning a trip to Romania that will cost $2,000. $2,000. His parents have pledged half of the cost to help him. His grandparents will pay 1/3, and his uncle will chip in 1/8 of the cost. What fraction of the cost will Jake's relatives provide? Okay, so what we're going to do is we're going to list out what we know. Well, Jake's parents are going to provide 1/2 of the cost. So he's getting 1/2 of the cost of the trip from his parents. His grandparents are chipping in 1/3. His grandparents. And his uncle is chipping in for 1/8. Uncle. Very nice relatives. Alright, so since we're adding 3 fractions, let's take 2 at a time. Let's take the first 2. We're going to add 1/2 and 1/3. Let's go ahead and use the cross product method. 1 times 3 is our first term, which is 3, plus 2 times 1 is our second term, which is 2. That's divided by 2 times 3, which is 6. 3 plus 2 is 5 over 6. So that's the sum of 1/2 and 1/3. Now we want to add 1/8. So 5 over 6 plus 1/8. And we want to find this. So 5 times 8 is 40. 6 times 1 is 6. And 6 times 8 is 48. 40 plus 6 is 46 over 48. And this simplifies to 23 over 24. And when we do the math on this, I do believe that $1,916.67 out of the $2,000 is covered by his relatives. So this is the total, and the fraction of the cost that the relatives are paying for is 23 over 24. That's the fraction of the cost that's being covered by the relatives. So Jake only has to come up with 1/24 of the cost. They're paying for $1,916.67 of the $2,000. Very nice relatives. All right, so what do we learn here? In adding rational numbers, what we do is we can use a traditional method, which most instructors use in schools, and we find an LCD. We want to transform our fractions into two fractions that have that common denominator, and we add across the top. We can check this by cross multiplication, and we can use this nice little trick that basically bypasses having to find an LCD. So if we can't use this, it's always a good check. And then we saw an application that if we're trying to find the total amount of a few fractions, as you know, in the case of this, of a cost, we can simply add the fractions, and then we can find out what fraction is that of a total cost. So practice this. I would practice both methods and see what works for you best. I would master them both because adding rational numbers, you'll see a lot in algebra. I'll see you soon.